Okay, so basically what we want to do to go backwards is we're going to be given a percentile, and you'll see that right here. So I'm going to pause right now. I want you to write this down. We're going to find out the z-score that separates the lowest 30% from the rest of the distribution. Okay, so does everyone understand? We're trying to find what z-score, this green line, will give you the lowest 30%. So it separates the lowest 30% from the rest of the distribution. Are we good there? We know it's not going to be -1, -2, or -3 because we know what those percentiles are. So what we need to do right now is we need to go to our formula sheet and we need to go to our z-scores. And we know that in the formula sheet, the z-scores are the columns. So let me use my cursor so you can see. The z-scores are the columns and the rows. Row up top, I should say. Then all the rows in the middle, these are our p-values or our probabilities. They're also known as our percentages. So what I need to do, and we know also that the distribution, this table, only works for the lowest percentile or probability or p-values. So I need to go and I need to look for the decimal that is closest to 0.3. So I want everyone to look at their chart right now. Remember, you're not looking for a z-score, you're looking in the middle for the closest decimal to 0.3. And I spotted it. Did you guys spot it yet? I spotted it right here at 0.3015. Do you see that? Now what we do is we go backwards. We have to figure out what z-score goes with that 0.3015. And we go across and we get -0.5 and then we go up 2. Let me show you again in case you didn't understand. 0.3015 is right there. That's the closest to the 30th percentile. We go across and we get -0.5, -0.52. Okay, so we found that this was z is equal to -0.52. Now we need to know what separates the highest 25%. Yes. Yes, very good. I should have said that to begin with. When we do go backwards, we need to change this 30% to a decimal. And do you guys remember how to change it to a decimal? We go 2 decimal places to the left, okay? Or we can divide by 100. That's going to give you 0.30. Okay, so let's talk about this one. We want to know what z-score separates the highest 25% from the rest of the distribution. Now, this one's a little different. Look at my plot. I have my mean. I have 1, 2, 3, 1, 2, 3. Am I going to start from the left when I'm thinking about the percentages or the right? The right, yeah, because I'm talking about the highest, right? I'm talking about the highest. It's somewhere in there. Now, we know that this little area is 0.15. This area is 2.35, so we have 2.5. This is 13.5, which gives us what? 16%. So we know it's got to be somewhere in here. Does anyone have any questions about that? Now, if you don't shade it totally correct, that's fine. As long as you get the right z-score, that's all I care about. Now, are we going to go to the chart and get 0.25? No, why can't we go and get 0.25? Yeah, the chart only works for the less than. So what is this less than area? If this part is 25%, is that what it was? What is this part? 75%. So we actually need to go to the chart for the 75th percentile right now. So we need to change it to a decimal, to 0.75, and now we're going to go to that chart again. Okay, everyone do that now. Take your chart out. And now we're going to be in the positive values. And 0.75 is closest to right here, 0.7486. Do you see that? Does everyone see the value? Point to it with your finger on your desk right now so I can see that you see it. Okay, and now I go across. And I say that is 0.67. And that's the z-score that it goes with. questions there? I think I have one more challenging one for you. Let's see. I don't. All right, I'm going to pause it, and now what I'm going to do is that was finishing up yesterday's notes. We're going to do today's notes, and it's just one page of notes. We have our distribution. We want to know what percentage of people will take less than 48 minutes to complete. Okay, so how we're going to approach this is the first thing that we need to do is we need to find the z-score. Did I tell you guys my acronym for a z-score? Do you remember? ZOMS, yeah, ZOMS. So Z is equal to my observation. So here's my observation, 48. Minus my mean. So my mean is what? My mean is 80. With a standard deviation of 20. So calculate that in your calculator for me right now. What do you guys get? Negative 0.6. All right, so we're going to put negative 0.6. We know that this person scored negative 0.6 standard deviations below the mean. Well, what does that mean? We want to know what is the percentile. How well are they doing compared to other people? Is this unusual? No, what does it have to be unusual? Do we have a question? For sure. Is this wrong, negative 0.6? Yeah. Okay, that's okay. So it's negative 1.6. Okay, perfect. So after I find my z-score first, I need to go to my p-value, or go to my table, and I need to find the p-value. So let's go to negative 1.6. What is it? Okay, so negative 1.6 is 0.0548. Thank you. 0.0548. And now our last thing is we have to analyze. Are we done? And how do we know if we're done? We need to remember, if it's a less than problem, we can stop. If it's a greater than problem, what do we have to do? We have to subtract, so we have to do 1 minus the p-value. And then if it's an in-between, what do we have to do? Yeah, the big minus the small. So we look and we say, okay, this problem's a less than, so we get to stop. Joni needs to leave class early to get to her dentist appointment. You don't have to write this down if you want. If you feel comfortable, should we just talk about it? And then whatever I write down, we can write down, or I'll just let you know when you should. Joni needs to leave class early to get to her dentist appointment. She only has 90 minutes to complete her test. What is the probability that she will take longer than 30 minutes to complete the test? The steps are all the same. Give me a second. I'm going to find a z-score. 90 minus 80 divided by 20. What does that give us? Can you do it in your head? 1/2, yeah. Why did I do 90? Because 90, we're wondering, again, probability, percentile, p-values, all the same process. We need to go to the table, but first we need a z-score. So our z-score is 0.5. Next, we get a p-value. We go to our chart. What do we get? 0.6905? 0.6915. Then we have to analyze. Are we done? Yes or no? No. Why are we not done? Well, it's a greater than. Okay, so we have to do 1 minus 0.6915. And what is that equal to? 0.3085. Now Joni has a decision. She could say, am I going to go to the class or should I reschedule? There's a 30.85% chance that she won't finish the test. What would you do?
I'd do it.
You do it? Yeah. So that's the thing about statistics. It's all about looking at this p-value that we get, and then we have to make a decision based off of it usually. Okay. All right. Let's see. Would we be okay with the between one? What would we do with between? Let's just talk it through. Well, first we would have to find what? We have to find the z-scores for both. For 45 and 110. Then we have to find the p-values for the two z-scores. Then we have our p-value. Then subtract big minus small. So the issue with this sometimes is I will get people who will just subtract 110 minus 45. And then they get one z-score and then they go to the table. Or I will get people who do find a z-score for 45 and 110, and then they'll get two z-scores and they'll subtract the z-scores. So the big thing is you need to know is, hey, we need to get two z-scores, we get the p-values, and then we do big minus small. Are we okay there? Okay, let's do the last one here. Our last two. This is taking what we just learned. What number represents the 70th percentile? So that's what number separates the lowest 70% of the distribution. You need to know whenever you see the word percentile, it's always a less than problem. They will state the higher or the top, whatever, when you know it needs to be the other way around. So I want to do both of these because they're both a little bit different. What number represents the 70th percentile? So we don't know now what test time this is, right? We're looking for the test time that represents the 70th percentile. Any thoughts? What should we do? This one's a little more difficult. Okay, so we'll put it into a decimal. Yeah, we can put it into a decimal, and I always like to draw a picture. It's not necessary, but I find it helpful sometimes. So I'm trying to find, we know the mean, right? We know that the mean is 80, is that correct? You guys? Yes? 80 with a standard deviation of 20. So that puts us at 100, right? 120, and then 150. And going backwards, that puts us at 60, that puts us at 40, and that puts us at 20. Did I do math wrong? I did. Forgive me. Everything else look okay though? I want to know what score is going to be in the 70th percentile. So we know up to the mean, that's 50%, plus 34%, that's what? Up to the mean is 50, so another 34, I'm at what? 84%. I want the 70th percentile, that's somewhere right here. I need to figure that out, right? It told us that at the very beginning. Yeah, but it's all tied in together. So we know the mean's 80. We know the standard deviation's 20. I went 3 above, 3 below. Now the big deal is, though, is, okay, well, I need the 70th percentile, and I can't tell based off the 68, 95, 99.7 rule. So any suggestions? Yeah, we need to go to the table. We know this is 70%. We need to first change it to a decimal, and then we need to find the z-score that goes with the percentile. So do that now. So we're going to go, did we already do the 70th percentile or no? Okay, so we're going to go to our chart. Remember, you don't have a z-score now, so you're not doing the outer column or the upper row. You're in the middle looking for that 0.7. So 0.7 is at 0.52, okay? And that's the closest one to the 70th percentile. So I have a z-score of 0.52. So we know that this person right here got a z-score of 0.52, but we don't know their observation, and that's what it's asking for. So what do I need to do next? What? Yeah, we need to transition this z-score to an actual score. saying to ourselves, well, what do we know? We know what the z-score formula is. ZOMS, right? We know the z-score now. We just found that. We know the mean. It was given in the beginning of the problem. And we know the standard deviation. We also know that this is an equation, so now we can use algebra to solve for the observation. So I'm going to say 0.52 z-score ZOMS. Z is equal to my observation. I don't know my observation. So I'm going to put that as what? X minus my mean, and my mean was 80, and that said that at the beginning, divided by my standard deviation of 20. And now what can I do? What would be the easiest way to solve this? We could do algebra. There's a couple different ways. We could multiply by 20 to both sides and then add 80, or we could do cross multiplication. Whatever would be easier for you. So we get our x, and what do we get for an x, you guys? Has anyone tried it yet? 80.4. So 80.4 minutes. And you can check yourself. An easy way to check is if you're illustrating the 68, 95, 99.7 rule, you know it has to be between 80 and 100. I know you guys feel like you're ready to go with the homework. I just feel like I wouldn't be doing my job if I didn't show you one more example. And then I'll leave the last one for a challenge for you. What number represents the longest 10% of all takers? And we can just talk through this if you want. What would we do different here? Yes?
How did you get 80.4?
I don't know. I was just trusting that it was right. So 0.52 times 20. And then plus 80. Oh, so it should be 90. No big deal. Just a little math went wrong. We set it up right. We know the math. It was just a low calculation. So 20 times 0.52 was what? 10.4. And then we add the 80. So we should get 90.4 then? Right? Okay. We good? And it's still between that 80 and 100. We're still good. How is this one going to change? What represents the longest 10% of all test takers? Yeah, so it's greater than. So what do we have to do when we find our z-score? Yeah, we subtract it from 1. So we're looking for the z-score that goes with the what? Yeah, so 100 minus 10, or 1 minus 0.1, that goes with the 90 percentile. And now it's just the same. Do you need me to do it, or do you feel okay? Give me like a thumbs up, like this feels comfortable. Okay. I think the one that would be helpful to go through, though, would be this one. What range of values to find the middle 50%? So this one's a little more challenging. Any ideas what we would do? I would say even if I gave this to my statistics kids, they would maybe have to think about it for a second. Yeah, Jen?
Top 25 to bottom 25 percentile.
Exactly. We can just approach it that way. So I always like to draw a picture. Again, we know 80, 100, 120, 140. Backwards, 60, 40, 20. We know this is the middle. We need the middle, and we know what? We know that this is 68%. So it has to be somewhere between 60 and 100. So I'm going to mark it, and it doesn't really matter exactly where you put it, but we're going to call this the middle 50%. Well, one observation I can look for is I can easily look for this observation, what x is equal to. Because what do I know about this area? That area is 25%. So I want you guys all to practice right now. Find the z-score that goes with the 25th percentile. Do that for me now. -0.5 -0.67. Can someone else confirm that it's -0.67? Okay, so we get -0.67. What do we know about a z-score? A z-score is equal to an observation that we don't know, minus the mean, which is 80, divided by the standard deviation of 20. Can you guys cross multiply right now for me and find the observation? So what do we get? 66.6. Okay. Anyone else get that number, 66.6, just to confirm?
Yeah.
Okay, perfect. So the bottom observation, x is equal to 66.6. Now we need to know the top observation. So, you guys are doing awesome. We're almost done. What percentile would this observation be?
75.
It'd be the 75th percentile because we know this is 25%. This has to be the 75th percentile. So go and find the 75th percentile and you're going to see something. 0.75. 0.67. How do we know it should be 0.67? It's on the positive side, and this is all symmetric. So this little area right here is 25%, and this little area here is 25%. So 0.67 is x minus 80 divided by 20. What do we get for x?
93.4.
Oh, 93.4. Did anyone else get anything different? 93.4? Awesome. And now I feel like I've shown you everything you need to know. You can now do normal distribution worksheet 1 and normal distribution worksheet 2. Okay, you guys good?